All right. Now I want to be clear, like when we implement a stack, we usually do it with an array or an array list. We don't do it with a linked list. Okay. Um, but I wanted to give us a little bit more practice of linking and unlinking nodes in a linked list. And so a stack is a nice way to do that. Um, but this would be an odd way to implement a stack, but maybe there is like some weird performance requirement where this would make sense. But usually we do stacks as an array list, and we when we push an element and pop an element, the top of the stack is the end of the array list. And in fact, when we start the maze lab at the end of this week, or it'll really be next week by the time you get to this part, you will implement a stack as an array list because we want to implement it in a fast, efficient way. So, but we are going to like practice this node thing by adding, by implementing push and pop. So you can see that push is going to make a new node. And so we have to change how first is linked and then how the new node links to the node that was first. And pop. Pop removes the first node, the top node in our stack, and how we then have to change how first is referenced to pull that off. Um, so this is basically add first, remove first, like we already implemented. We're going to do some of it together, but I'm also going to pause and let you try to do the reference work on your own, because that's we need to practice it. It's a little tricky. So back to the code. We'll practice some of this together. Um, so we have a linked list stack class partially written. We already have the instance variable, which refers to the first node in our linked list stack. We already have a constructor, which sets that to null, just like we did before, to say that our stack is empty. And then we have java.comments here for adds an element to the top of the stack. That's our push. Removes an element from the top. That's our pop. Checks whether the stack is empty. That's a empty method. And the inner class for the node is already written here with data and next, just like it was for the linked list. So let's start with push. So we're going to type the method header together. Public void push object element. And then what you're going to do is implement push. So I'm going to give you a minute to type it. It's like 4 lines of code, but based on this picture, you have to make a new node, you have to initialize data, and you have to update these references to insert the new node at the beginning of the list. So I'm going to give you a minute to do that, and then we'll check your solution against mine. All right, so a few steps for push. Node, new node equals new node. We need to make a new node because we're going to be inserting it into our lists. So we got to have that. We need to initialize the new node's data to refer to the element that's specified, because the user really cares about just pushing the element onto the stack. And then we have to update new node.next to refer to what was, currently is, and will be only be for a short period of time here, the first node in our linked list. So I think that's like the hardest line of code for the push method. New node.next equals this dot first. That's this dash line right here. Updating that one. All right, and then we just can say, we can wrap this up by updating. So we've done all the stuff with the node. We can say this dot first equals new node. There we go. There's the 4 lines. All right, next part for you, public object pop. There's the method header. Under what condition would we throw an exception when we call pop? Would we ever throw an exception when we call pop? What's that? Yeah, if there's nothing in our stack, we can't call pop. So we'll do the exception part together. If this dot empty is true, throw a new no such element exception. We've done something similar to that before. The rest of the method is left for you to implement. So pop removes the first node in our list and returns the value of that node's element, that node's data. So I'll give you the picture to help out. The bottom part of this diagram shows us removing an element. All right, this is the approach I took for pop. Before I unlink the node, I want to remember its data. So I'm going to say object element equals this dot first dot data. So now I have a reference to the data that I'm about to pop off the stack. Then I need to update this dot first to refer to the second node in the list. So this dot first dot next. Next might be null, but that's fine. Then this dot first will be set to null to show that I just popped the last element off my stack. And then finally, I have to return element because that's what pop does. Do we have that? So do we need to reduce the size? Do we have any instance variable that keeps track of the size? Yes, there's nothing to update. We might have a method that calculates the size, like we wrote last week, whether we do it recursively or not to check. Right. And we need to implement empty. So public Boolean empty. You may have already written this one. We're simply going to return this dot first equals null. If this dot first is null, our stack is empty. The code that you just wrote for push and pop, we wrote together previously for add first and remove first. It's the same code. Okay. We're just doing it from like a stack perspective. Okay? And I just wanted you to have a bit more practice of thinking through, okay, like how do I deal with, in what order do I update these references so that I link and unlink a node from the start of our list? So.